Right, so welcome to part 2 of the SC30 Repro Board assembly series. Let's see if I can get some people to watch this stream. I'm gonna share the link. Let's see here, where do I do that? So today I created the stream from OBS. So it's the first time using OBS. I'm not sure other people to see this. It's public this time, so people should be able to just find it if they subscribe. But it's a good question as to how I can actually find my own stream. Is it on the channel dashboard? Let's see. Go live? No, that's not it. Contents. Live. Oh, there it is. So I can see my own stream there. It's live, so I can probably, yeah, get shareable link. Very nice. All right. So let me share this with some people. There we go. So I'll just hold on. Actually, so the recap from last time. So I'm, as a reminder, I'm working on this reproduction board by Bolle. He has reverse engineered and published the Gerbers for this very nice repro board, and I've had this manufactured by JLC PCB, and they have a very nice manufacturing birdseed assembly service. So I used that in order to get most of the birdseed on the back here, the small passive components, SMD components, assembled ahead of time. It's a bit dusty now actually, but they didn't have the 10 nanofarad SMD caps in stock, so I took those off the donor board last time. There's a donor board, very battery bombed. So I took the 10 nanofarads caps off, and I let's put it over here. Pun not intended. So today, basically the game plan I'm following. Let's see here. So I have this little thing here where I can switch to other. Can you all see my? Oh, there's web browser. Can you all see the web browser? Or Tony, can you see the web browser? I assume so. So my friend the Tech Knight has done his own stream. He streamed a video of assembling this very same logic board, and somehow this does not show. Can we? Oh, there we go. That's better. Yeah. So my game plan is to just basically do what the Tech Knight did. So since we're done with the underside of the Tech Knight did, which is to assemble the large SMD ICs. So I do have a little baggie over here. Here's my. Let's see. Let's switch back to this one. Here's my little baggie of chips. It says 800K Sony, but that's not what's in it anymore. So my little chips are in there. And I need to do one thing first, which is, so this is my little jar of dead parts. So I have one part in here that came out. This came out of the donor board. See if we can switch over to the close-up. So here's a new thing with today's stream. I have this little very cheap microscope. So if we take a quick look at this chip here, see how this works. Here it is. So this is a Hitachi chip that came off the donor board And I don't know how well this is gonna come across, but yeah, look at this. Oh, actually, like so. This chip is very corroded. Pretty much each of the sides. Oh, I'm so bad at this. How do we? Super awkward. Yeah. So, needless to say, I'm suspicious of this chip. So I'm going to try and get a different chip to use instead. Actually, let's have a quick look what this chip is. I'm not very knowledgeable about what these parts actually do, but why is it so hard? There. So if we go back to the browser and have a quick look at the BOM here, we should be able to find this chip. What's a good way to find it? It says so I guess the part number is HD62064. We have something that begins with HD. Nope. So maybe that's not the right number. Anyway, we don't need to necessarily look up what it is. Actually, I can look at the I took this chip off U11, if I'm not mistaken. Oh no, it was a UG12, I'm pretty sure. UG12. Well, it's so hard to find the right spot with this microscope. So it doesn't come across too well, but this part was just really corroded. It says SCSI on the silk screen there, so I assume this is the SCSI controller chip. I could be wrong. So anyways, enough talking. What I want to do, very same chip off of this 2SI dead 2SI board that used to work briefly but stopped working, and I think there is a broken trace somewhere, and I can't be bothered to find that broken trace. So it doesn't chime, it's very dead, so and I've already stolen other parts from this board, plus I have enough 2SI boards, so I decided to steal this Hitachi chip for this board. So it's the very same chipset sits right here. Oh, HD62064. So it has the same part number, so I assume it behaves the same. It has a 1924 date code, so it was made on the 24th week of 1990, versus this chip is 1928, so it's the 28th week of 1990. So it's 4 weeks newer, but unfortunately quite corroded. And yeah, this is since we're going through the steps of actually soldering this on. It's probably better to have a chip that's more likely to actually work. So I'm going to now. So I'll just switch over to face view and then perhaps angle it down as I remove that chip. Right. So I think 350 degrees Celsius maximum airflow fairly small tip. This should do the trick. So I have my tweezers ready, and we'll start applying some heat in this area. I sometimes use flux, but I think this board doesn't really need flux to get SMD chips off. There are methods to do this, but I usually just go around, try and angle some hot air underneath the chip, and then I mix it up with applying some hot air on top of the chip. Don't know if that's the best way to do it, but it's a way to do it. And once it gets hot enough, then solder will melt in the pads, and we'll be able to just slide it off the board. So, with an SMD IC of this size, I found it takes maybe 2, 3, 4 minutes of applying heat to get it to come off. And you really want to make sure that it just comes off without any effort. It's very easy to pull traces. Some weeks, some months ago. Okay, starting to come off a little bit. Just put the tweezers underneath the chip and just bend a little bit to get a sense of how far ahead we are. Okay, and it's almost off. Almost there. Alright, here we go, there we go. Beautiful. Let's turn off the hot air for a bit. And then let's look at the close-up again. So, these are pretty hot now, so you don't want to touch them with your fingers. But it seems the chip came off pretty nicely. Oh my gosh, why is it so hard to position? There's something. Oh yeah, it seems. I know. If you look on the underside, I think no bent pins. It looks pretty nice and clean. You don't want the pins to kind of be bent together or away or something. Makes it harder to solder it on later. But I think this chip is in pretty good shape. So let's put it aside for now over there. The pads seem good. No messed up in the future. But yeah, this has been a great board for for parts, and I think it will be useful again in the future. I stole this. I think these are bus transceiver ICs. It's part of the serial bus. Jeez. I think I should try and put the microscope up here. It's hurting my brain to try and position it correctly. There we go. Oops. So this is the problem with this microscope. It's held on with a suction cup. So I'll probably try and glue this on or something in the future, because it comes off pretty easily. Anyway, so we put the 2SI board aside. And we should be completely ready to try to actually work on the upper side of this board. This will be very exciting. I've never worked on a project this large before. Alright, let's see here. Open up this little box of goodies. Actually, there's one decision we need to make before we start. So there was another chip, an original chip from this donor board that was fairly badly corroded, namely the FPU. So there it is, 68882 FN16A, rated for 16 megahertz. Is the FPU for the 68. Focus there. Now, I've tested this in another Mac. I tested this in a 2SI actually, and it works. I don't know how far that is, but see the corrosion here. You can see that there is some corrosion that's happening on the pins here that has made it into the package. There's some green crust there. This corrosion may keep eating away at this thing inside. So I do have another FPU, which is this one here. It's hard to read. Oh, there we go. It's an MC68882 FN40A. So this is rated for 40 megahertz. But according to my research, they are backwards compatible. It should be able to just run in 16 megahertz mode or whatever. So this is a new old stock FPU that I got for an Amiga project originally, but I never used it, so it's been sitting in my drawer. So the question is whether we want to try and use the original authentic 16 megahertz part that came out of an actual SC30, or this new old stock. Is that there's a scratch on there? I guess it's not so new. So anyways, yeah, I don't know. What do you all think? If I should use the genuine part? Genuine for new old stock. That was my review. But I'll keep this to the end of the initial set of assembly. So if somebody has other opinions, I'll consider those. Little baggie, we'll put it over there. And where did I put the big baggie? There. Let's pour them out here. So here we go. The big glue chips. Oh, the one big glue chip. This took a lot of hot air to get off. This was a very stubborn chip. We have the other various glue chips. It's NCR made one, or VLSI. What is that, Motorola? AMD. $1988. I do have a crystal. Here's a crystal. I'm pretty sure I bought new ones of these just because they're cheap. So I don't know if I'm gonna actually use this one, but it's there. I think these are fuses, if I'm not mistaken. These little guys. I have 3 of them. And then a bunch of, I think little RAM chips, maybe? And logic chips. Some of these little logic chips and whatnot, they were pretty badly battery bombed. Had legs falling off of them, so the ones that were very badly damaged. It's gonna be fun. A lot of chips. And this little guy, I'm not sure what that is. I forgot. Anybody know? So yeah, let's put this small part in its own little compartment over here. I'm gonna keep the higher profile, these chips, as part of the initial batch. Yeah, thanks, Tony. I'm pretty sure once we find the location that it goes in, it'll probably be obvious from the silk screen what it is. But yeah, maybe it's not even part of the new build. I don't know. All right. So yeah, this might think I need to keep it at this level, because otherwise I won't be able to film in the middle of this board. So yeah, we'll see how it goes. It's not going to be the best vantage point as far as seeing what's going on, but it'll be better than the last stream where, you know, there was no visibility, basically. So I think I'll start with the big on the glue chip. Right there. Okay, yeah, this sits there now. So I think what I'll start by doing is to just heat up the board a little bit overall, at least in the general area of the large ICs. I didn't mention there's of course one more large IC that you may all be asking about, and of course the pièce de la résistance sits in this little box here. This is the CPU 68030 RP16B, made in the 28th week of 1990. I have a socket for this guy, so yeah, we don't need to solder this in. I also have the little serial number sticker or whatever, so I'll probably try and attach that as well on the board. So yeah, this guy is gonna go into a socket, so we don't have to mess with all of these pins. So this was desoldered from the donor board. That was annoying. I was able to avoid bending any pins, but you can see there is some solder residue so I don't know how well this will go into the socket. It's gonna be a pain to clean that up, but we'll see. Maybe there's enough length on these for it to go. So I have my box of goodies. This is where all the parts lie in. I have sockets for the ICs, the 312 ICs. I have the backplane shields. I painted, and yeah, all the chips sit here, and the parts, and I have a ROM chip, not ROM chip, but I have a ROM sim made by Maxim, or the Maxim version of this. I got this off some guy on Etsy who are making these. So I'm gonna go with the sim socket approach rather than the whatever it's called. Oh crap! Yeah, this is not gonna work. There we go. ICs into these 4 sockets here, but I have a sim slot lined up, so I'm gonna put it down here rather. So anyways, yeah, this will be very interesting. Oh, I need to put this away. So I need to move actually the chips away from the top side because I need to use the full depth. Like last time, I'm gonna be using this solder paste by MG Chemicals. I put a link in the description. I've had pretty good luck with this solder paste. It seems to be fairly easy to work with. It's supposedly extremely toxic. There's one of these, you don't see it a lot of times, but there's this dead fish symbol there. So you should definitely be, it's like a wilted tree and dead fish symbol, poor thing. So maybe I need to, you know what, I'm just gonna super glue this. Yeah, thanks Tony, good advice. I'm not gonna eat this solder paste. So I think I'm just gonna actually super glue. So this microscope has this little board thing that it came with. So I'm gonna glue that. Just a moment. Just go hardcore and super glue this microscope onto. See if that holds. This is a cheap microscope, so I don't really mind. Okay, like so. There, plenty of super glue. Okay, so we got a little bit of paper tissue. I need to make sure that this is not gummed up. Oh, there we go. So the paste comes out. That's good. So we should probably do a quick cleaning with alcohol, just to make sure we have nice and clean pads. Start on the close-up. So there we go. There's a super glued microscope. So I have my little alcohol container here. Actually, I said I was gonna heat up let's clean these pads a little. We need to move these chips out of the way as well. Come over here. Okay, so time to use the hot air. So I'm gonna see, is it not too hot? I think for the general heating, I'm gonna change the tip to there we go. Spin it. Okay, seems to be held on there. All right, let's just go 350 as usual. Up board. I don't really know how long you should be heating the board to actually have it make a difference. But I found that definitely it does help. You know, if you don't preheat the board, you'll notice that the first few jobs are gonna be a little bit more obnoxious, and then as the board gets warm, the solder melts more easily. So I think this helps. Yeah, I guess this is what you get for using a cheap hot air workstation. Why does it? There are two notches on the inside there, and there are two little wedges on the tip there. So the notches should go into these wedges and then spin around. But maybe it goes down there. Maybe I should try. I don't really have anything. Okay. Yeah, so it's not really on there. Probably not the best idea, but let's see if we can twist. Wow, it's not sticking on there well. Okay, lesson learned. Do not take off these tips because they don't come. Should probably try the mid-sized one, see if this comes on better. Oh yeah, these came on better. So I don't think, so these are 3 sizes, smallest, biggest, and then this one is good enough for this job. So let's put these over there, and it's on there firmly now, so it won't fall off and cause damage. Yeah. So this is the largest chip. It's going to be hard to show in its entirety in the microscope. Let's try to apply solder paste. So I've done this a few times now, and I'm starting to get a hang of roughly how much is needed. But it's still a little bit of a winging it situation going on. So there's some paste. So if somebody watching has an idea how much you should put on the pads, let me know, because I'm definitely winging it. So I suppose if you put too little, you're gonna have to spend more time getting more solder on there. And if you add too little, if you have too much, you'll have to clean up the mess. So I guess it's about what is more annoying. Reasonable, usually I use regular, yeah. So Tony, you use regular solder with the soldering iron, right? And you just solder them. Oops. Yeah, I think I just soldering iron. So I just find it really hard to get nice, reliable joints when I solder surface mount ICs. Live. All right, so we have some solder paste on here. Looks all right, I think. So let's put the syringe back here. I should probably have checked the orientation before I put the solder on here, but I think we're seeing a little bit of a, so if we look over here, there's a bit of a wedge there. Yeah, I do think when used correctly it does help if you have, with solder paste, but it's definitely you know, a different skill, so to speak. So anyway, so we have the corner cut off there on this side here, and this chip has one angled corner right there. So that is usually the sign that you want to align those edges, and all the other edges are angular or 90 degrees there. So I think it's fair to assume that this chip goes on like so. Yes, like so. So again, this is the first time I ever use solder paste for such a big chip. So I have no idea what to expect is gonna happen now. We will all find out soon enough. but I think the pins and the pads seem to line up. Quite all right, so let's try, and I will try and at least get some action on the camera. So I have no idea how this microscope is going to react to the hot air. It may be, it may melt when all the hot air kind of rises here. Oh, I shouldn't do that, but anyway. Anyway, what we learned last time, and Eric Helgeson very kindly leaned in and helped with some suggestions about the airflow and the temperature, because I had completely forgotten about that. So the trick with solder paste is high temperature, low airflow, if I understand correctly. And what worked last time was 2 out of 8 for airflow. Seemed to work. It's probably okay to do more with a big chip like this, but some other components are gonna fly away if you drive them too hard. So let's bring it down to 2, and then temperature 450 degrees. It'll heat up in a second. There we go. All right, so let's see what happens. Let's apply the hot air. So there we have some action happening. Kind of like how it's melting away like that. Right? Yeah, it's pretty cool to observe. But I should definitely have turned on my fan, because this stuff smells and it's probably pretty toxic. So yeah, I'll bring my fan on the next time. So I'm already seeing a few solder bridges, so I probably put too much on there, but that's something you can clean up. Anyway, so that's the first round of solder paste, and I'm gonna bring out my fan. And so I have a teeny tiny workbench. Probably put the fan over here, like so, and then I'll turn it on. Actually, that's not heavy running. So let's do a quick inspection. I'm gonna bring out my loop, see what actually happened here. Let's switch to this view. So let's see if we actually got some. Yeah, look at that. It looks like we have pins that are attached to pads, so that's helpful. But yeah, I see at least there's another solder bridge. Another solder bridge. More solder bridges. Yeah, too much solder paste for sure. Yeah, that's one huge bridge there. Okay. And some pretty weak joints over here. So, yeah, definitely uneven. So question is, should I clean this up right now? Yeah, probably. I'll go over it with my iron once, just to see if we're actually getting good results in the end. So oftentimes it's usually just getting the iron on there helps make it look a lot better. Let me see. Should probably get some water on this sponge. Have some distilled water here. Just put that on sponge. Turn on the iron. Hello, iron. Should probably put a different. Yeah, I guess this is fine. Okay, so 350 degrees Celsius. Let's see what happens if we just apply a little bit of heat here. Okay, so the solder bridge seems to be looking better. But yeah, there's still a bit of a bridge there. So probably need to bust out the wick. Just a little bit of wick. Let's get that off. Working down here. You can see the solder bridge sticking out there. Look at that bridge. It's a big one. Joints look all right. Just keep going round. So yeah, I'll do this off microscope because yeah, it's not the most exciting work. Bridge. So for the naked eye, it seems like the bridges are gone on that side. Let's touch up. Yeah. definitely too much of the solder paste, so I'll be more frugal next time. Probably avoid too much cleanup. Okay, I think the bridges are gone on that side. Again, I apologize, it's not. I should probably. I think we can do this side on in the microscope because it's easy to do. Lots of solder bridges. So let's go over pins first. See if the bridges go away just by applying heat. Then we get rid of excess solder every now and then. So yeah, still bridge party here. I jokingly refer to solder bridges as Jeff Bridges, the actor. So, are you here again, Jeff Bridges? Yeah, thanks for the LOL. I should definitely be using my fan. I keep forgetting to turn on the fan. Not a bridge, but there's like a big ugly chunk there. And now it's a bridge, I should get rid of it. Yep, so at a glance it seems the bridges are gone. So that side is clean, that side is clean, that side is clean, and that side is clean. So, I think that chip is on there. And we used a lot of this wick here, but probably cut it right here. Put it in the garbage. Alright, so glue chip is on. And of course I don't know for sure that I should probably check them in my loop to see if all the joints are good. These joints here look pretty weak. I should probably add some solder. And of course I created the bridge again. Bridge is gone. There's one joint that looks weak. Let's see if we can add some solder there. So yeah, I'm not super confident about yeah, let's call it good for now. This is definitely one of those chips that's set fairly close to the battery bombs, as there's batteries outline. So there were some dull legs on this chip, so we'll see. Not the best shape. Anyway. So let's keep going. So I don't have a good system for actually identifying the right chips here, but we know for sure that let's see here, we could put on the Hitachi chip that we pulled off the 2SI, because I think that sits right over here at UI12. Let's double check our facts against this page. If I UI5, I don't know. That reminds me. I don't know if there's actually a one-to-one correspondence. So this is the BOM for the original board, I think. Yes. So UI5. Oh, sorry. UI12. Can we swap by location now? UI12. Oh yeah, so it seems like at least what we've seen so far, we have a match between the original BOM. Clear about this is not a one-to-one replica. This is a reverse engineering recreation of the board. So there are some minute differences. But anyway. Oh. Sorry. So I have my friend Brandon said that he wanted to join, have friends join, but it seems like they can't. I'm not sure if they weren't able to join through the link I gave them. So Tony, did you join from the link I sent? Okay, cool. Yeah, it's weird. Let me check. I gave them the same link. Oh, the URL changed. That was in the other one. Oh, sorry about that. Okay. Hi, Mac R. So he's Hi Mac R too, I suppose. Hey Brandon, thanks for joining. We are going to attempt this almost twice the clock frequency, so that's good, right? There we go. So this is UI12. Yeah, Tony has been watching, so it should work. Anyway, so turn off the solder. Freezes for me periodically. Yeah, maybe I need to hook up wired internet here, perhaps. Yeah, my computer does have an Ethernet port, so that's helpful. So next time I'll find out a way. Maybe Brendan, if you can source a longer Ethernet cable to me, I can, because I have my router. Right. Yeah, you're right. I'm yeah, I'm still learning. So let's apply the solder pastes. It's weird though. So it hasn't. The OBS software hasn't given me any indication that it's dropping frames. So I don't know what's going on there. Huh. Weird. Yes. Sorry about the trouble, Brendan. Alright. Add some paste on there. Yeah, thanks for watching, Tony. Have a good night. And happy chip on. And let's bring. It's so hard to do on camera. So, and that's on there. And I'll clean up. There are some bridges for sure. Still bridge party. I'll clean them up next time, or next time, but after I soldered a few more chips. It hasn't rebuffered the 1 minute I've been back. Okay, that's promising. So you watched my stream 2 days ago, right, Brandon? And it did work then, right? We didn't have that problem. So let's we don't have some residue. Perfect. Okay, great. Yeah, the difference. This time I'm using OBS to stream. Oh, great. So let's hope that it stays working. So we're on UG12. So let's yeah, I will definitely switch to wired. Let's talk about length afterwards. So let's jump back to the fact sheet for BOM. Should look for UG12. It shows right here. It's the SCC, the Serial Communications Controller, programmable programmable dual channel multiple as a parallel to serial and serial to parallel controller. That's cool. Quite a useful chip, and this is the Zilog made one, so that's easy to find. It's the Zilog Z8530. See if that lines up with what we have here. Z053. Z853. Oh, it's the exact same microscope as you have, right? I don't know what's going on with that. So I'm still pretty sure that this is the right Zilog chip, because I don't have any other Zilog chip. So I think that should be a fairly safe assumption. Orientation, so we have the little angled corner. So the rotation should go like so. And we should get some solder paste on there. Yeah, it should be the right size. And there's no other Zilog made one. So let's get some solder paste on here. So we still got some bridges last time, but it's really hard. This paste is pretty thick, so you kind of have to apply a lot of force to get it through the syringe. So yeah, it's hard to exactly adjust how much you get, and also it's kind of sticky, so it's easy to kind of push it around rather than get it to stick on the pads. That looks not too bad. So we'll drop the chip on there. Turn on the heat again, and we apply some heat and see how it goes. Move it on. Smell it. So definitely have bridges going on. But we'll just clean that up in one go after we get up on the bomb. UE10. Down here. This is the Apple Sound chip. Part number, oh, it says there 344S0063A. So we need to find that one. That's not the one. It's not. 344. I'm not sure if any of those for 344 were there. Oh, no, that's 344. Okay. S0061, S0063, which I assume is a variant. So I don't think we have any yet. 344S. Oh. UJ11 has a similar number. That's the Super WAS integrated machine, the SWIM. So we shouldn't mix those two up for sure. EC2982 0002. Yeah, so this is the Super WAS release 2. Unless I lost a chip somewhere. My bag, nothing in there. Oh, sorry, it's scope. Let's look at these two again. UET. Alt number is VC5007 0001. Which is neither of those either. Is it this one? No. No, it's different. Weird. Do we have enough chips of that size? Yeah, we have the exact number. So let's do UJ11 first then, to see if we can use the process of elimination to make sure we don't mess up. So UJ11 is alright, that's the one that we talked about. Super integrated WAS machine. Which is clearly this one, 344 S0061A. Yeah, so this one definitely goes here. So let's start with that one. UJ11. Here's the WAS machine. Goes this way. Clean it up. Placeholder paste. Solder plate paste applied. Looks alright. We will put this in the right orientation. I should probably have inspected the pins first, but I did that off screen some time ago, so the pins are supposedly all good. Now, see what's on there. Should maybe push it to the side a little bit, like so. Heat up the heat gun. And filming the wrong chip. Right. So the paste is nicely molten. Let's move on. So we have UK 11, 65C22, and UK 12, 65C22. So two of the same chips. UK 11. So yeah, these are two VIA chips. And we have part number 65C22. C22. 65, there it is, yep. VL65C22V. OQ, O2QC. 9030, 30th week of 1990. Same goes for this one. Cool, so these are identical chips. They go on together. So I think I should still do them. There, like so. This one as well. Over there. So the put it over there. Heat up the heat gun. Maybe I'll try just move the alcohol aside. I'll try and do it all around without moving the board. So yeah, sorry. Okay, solder paste is molten. Let's do this one. It's starting to melt a little the moment it's put on the board, because yeah, the board is definitely heating up more and more. Don't know if that's a good thing or a bad thing, but it's a thing. gonna be maybe bridges on that side. It's a lot of solder paste. No, it's actually not too bad. The chip is aligned right and also remelting. It could be a disaster to fix. Yeah, well, on the other hand side, for one, if you right, all of the solder is literally molten right now, so it's very easy to make small adjustments. If I just bring my tweezers over, I can move it around a little. Yeah, it's still 100% molten, so it's very easy to do small adjustments. And then if you find out later that it's misaligned, then you can just bring out the heat gun again and heat it up and melt it, melt with the solder, and then move it around. If we turn on the machine, and by the process of elimination, I think we can conclude that the last chip of this form factor is this spot to put 11 pins on every side. Yeah, 11, so it's 44 pin. This Hitachi chip came from my 2SI board. Yeah, there's a technique for desoldering these SMD chips. It's fairly straightforward. Yeah, so there are no other spots for these 44 pin chips. So you can assume that these NCR 53C80 is what should go into UE10. UE10. This is the sound chip. 400. Yeah, still doesn't line up. Yeah, and if it's the wrong chip, we can always adjust that later. Should go on this way. Constantly, no solder. Angle is a little bit here, this over there. That's a big bridge right there. It's all right. All right. So Brandon, now we have to make a decision, and I asked Tony about this, but it has pretty bad stuff coming out of the side there. And then I have this new old stock FPU rate reliable. So would you be terribly disappointed if I sort of pretty bad stuff? Oh, okay, yeah. So buffering fun. I was saying, if you can hear this now, I was saying that this FPU is pretty badly corroded here on this side. I can only hear about 30 to 40% of what you're saying. Is it because of the fan? Do you hear me better now? Testing, testing. Can you hear me better now? So anyway, what I was it's stable at the moment. Yes. So I'm proposing we put in this new old stock 40 megahertz rated FPU instead. So it will be okay. Buffering again. Yeah. So it will be less genuine rather than using the donor FPU, but I think that will give us a more stable computer. FPU goes over here. Yeah, cool. So we are in agreement. Jeez. Starting to lose a little bit of strength. It's getting harder and harder to get this out of the. Starting to seem a little bit bent. Maybe that's why. Yeah, this is kind of messy application, but way too much over here. And you don't want too much of this stuff underneath the chip. Anyway, so this is oh crap! I should have checked the orientation before I applied too much of this. I probably need to where the corner is. Yeah, that seems to be it. Yep. Let's validate against the original donor board. Just, yep, the orientation is in the same direction. We have the notch over here. Let's put it like so. Yeah, definitely too much paste on this. Oh crap. Not good. Yeah, we'll see. look in the microscope to see if alignment seems okay. I think so. It's as good as it's gonna get. Bring up the airflow a little bit. So while it's molten, we may want to push it a little bit to this side. Right. I think that is good enough for the FPU. Seems to be on there. We have bridges, but we can clean those up later. So I think I'm gonna finish this off by just attaching the 3 remaining large-ish ICs and then call it a day. So we have these ones, and then there should be one more floating around here somewhere. Oh, actually, there are 2 more. The FPU, which I will clean up in one go later. I did that for the first chip before you joined. When I did the glue chip, I did clean that up as well, but I'm just gonna do that in one go later. So it's you know, you go over all these joints with a iron, and then if the bridges are still there, then you use wick to get the bridges off. So fairly straightforward. So we have these 4 chips. Let's do the medium-sized one first, because you know that's the only one of this size. It's the one over here. UL11 ADB. So this is supposedly the ADB chip. Yeah, sure, I can do that once I finished these 4 chips. I can do a cleanup round. Are you back, Brandon, or are you still frozen? We have these two AMD chips, which I assume goes into those slots. And then we have this MMI chip, which I assume goes to the other one. So let's go. H7. That's the RAM PAL 341 S0689. 341 S0689. Seems about right. And orientation is this way. So these last chips, let's just get this done with. Last few chips. Let's go. SMD chips, that is. Alright, so that's it for the SMD chips. There they are. They're on there somehow. Yeah, there are, hard to see on camera, but there are some nice bridges there, and not so very nice. So what we want to do is to bring our iron, turn on the iron. Lean it a little bit on the pad, and then we just apply some heat here. So that will melt the bridge, obviously, and then we can pull the iron out, and then the bridge usually follows, at least to a degree. So we just do that. Apply heat, pull it out, wipe off the solder on the pad. Like so. So we have definitely less bridges going on now, but they're not completely gone. So then it's good to bust out the wick and then just pick up just a little bit excess solder. Should probably try and get a picture. like so. Seems ridge free. And we do that on all sides. It's hard to get a good view on that, so I'll probably switch over to, actually let's get a good big view. You see the biggest solder bridge right over there. So we apply some heat, pull it out, wipe off the solder. And it's probably good to just go down. Just gently, don't push too hard. To get a nice even. Yeah, looks good. I don't see bridges. I don't see bridges on that side. I don't see bridges. Actually, it's a little bit of a bridge there. Yeah, I should probably get a little bit of loop in there. Okay, bridge is gone. So, the loop as well. Okay, there's some glue over here. Okay, so now I think all the sides are and I need to repeat that process for all the chips, but I think that's about enough for today. So we got all the big ICs on. That's progress. I'll wrap up the stream. Thanks for watching and see you all next time. Bye.